All right, in this spreadsheet, we are trying to find the best way to ship grain between storage facilities and mills that make flour. It's an example problem of a company called Midwest Flour Co. Now, the way we have this arranged is shipments are shown in this table here, where the amount shipped from Kansas to Chicago will be in this cell. And the same thing works for each of these other cells. The total cost will be in this cell. And we can see that we also have some cost parameters. We know the prices to ship each ton of grain between each storage facility, each grain elevator, to each flour mill. So to ship between Omaha and St. Louis is $11 per ton. So we're going to use all of this information to create an answer, or to have Excel find the answer for us, because it's kind of a big problem, so to speak. So along the bottom we have demands listed. This shows the amount of grain that's demanded by Chicago, demanded by St. Louis, and demanded by Cincinnati. The supply works the same way. Kansas can't ship more than 170 tons, and that works all the way down to Des Moines, which can't ship any more than 200 tons. So we have some restrictions on supply and some restrictions on the demand. We don't want to ship less than what's demanded, and we don't want to ship more. We want to ship exactly what the demand is. So we're ready to now enter in some of our equations. But first, just as a sample answer, we're just going to choose some arbitrary values to ship between these different areas. So basically, if this is a real answer, it would say that I'm trying to ship 200 tons from Kansas to Chicago, 50 tons from Kansas to St. Louis, 500 tons from Kansas to Cincinnati, and so forth. That's how it works. But we want to know if we've kept our supply in check. We don't want to ship more than we have, because we don't have it. So we're going to sum all that's being shipped from Kansas. So I enter equals sum, open parenthesis, and I select all that's being shipped out of Kansas, and I close the parenthesis and hit enter. Clearly, the amount shipped is much more than what is available in supply, so this isn't a good answer at all. But the sum function, I can just click to copy it down to the bottom, and so I can see in each case whether I've exceeded the supply that's available. And in two cases I have. I'm going to use the same approach to see whether I've met the demand, exceeded it, or not met the demand. So I'm going to do equals sum, open parenthesis, select all of the cells which show grain that's shipped to Chicago, close the parenthesis and hit enter. And similarly, I can just copy this one, this sum equation, across the bottom of this table. And it shows that in every case, in my arbitrary guess of an answer, which was a bad guess, it shows that I'm shipping more demand than what is required, which is outside of the constraint. So it's not a feasible solution whatsoever. So we're going to let Excel choose not only a feasible but the optimal answer. All right, so the next step is we want to compute the total cost, or at least have an equation to compute the total cost. If you remember the sum product formula, we used it on columns before, but now we're going to use it on whole sets of numbers, because we want to compute the total cost to ship from Kansas to Chicago, which would be $7 a ton times 200 tons plus $8 a ton times 50 tons. And so we're going to use a sum product that multiplies the amount shipped times the price to ship between each location. So that's going to look like this. Equals sum product, open parenthesis, And the first array I'm going to choose is the cost array. I'm going to press comma. Then I'm going to drag and select the shipment array and close the parenthesis. The sum product will not work if the arrays are different shapes or different sizes. These are both 3 by 3 arrays, so that will work. And then I just push enter, and I've computed the total cost of this policy is $11,960, even though it's not feasible. So the next step, we're going to use Excel Solver to come up with a good solution for this problem.